It's always great to be at Bitcoin Park. And yeah, I left TVA after 23 and a half years. I'm give you an advertisement. I'm with the Tennessee Electric Co-op Association. So we represent 23 cooperatives who are customers of TVA, serve rural communities across Tennessee, about 3 million Tennesseans, which is about 1 in every 3 Tennesseans. And it's great to be a part of the energy sector in Tennessee. I've always enjoyed it and super proud to be here. And Michael Sullivan, I appreciate you and Rod and, you know, Braden and Dan and I worked together for about 15 years. You know, one thing that has consistently stood out to me, and Braden talked a little bit about this, was the incredible alignment that we've got in Tennessee from an energy, electricity standpoint, at the local level, the state level, the exceptional leadership of Governor Lee, Stuart McCorder, and then the federal delegation. I mean, Senators Haggerty and Blackburn and the House delegation. They have all just been tremendously supportive and aligned with the direction that we have wanted to go in this state, which is low rates, high reliability, creation of jobs, and sustaining jobs. And I think that's what we've done here in Tennessee. So I'm delighted to be here, delighted to moderate this panel. I'm fortunate because there's a guy on this stage who has 3 PhDs in engineering, and it's not me. But you have who somebody I would characterize as the godfather of nuclear energy in the volunteer state, and that's Hash. He's got a PhD in computer, electrical, and nuclear engineering, my friends. I barely got out of Florida State with a history degree. So tough questions on nuclear, go to this guy, okay? But Hash has been a real leader. He's led AMS since 1977, 47 years of industry leadership in nuclear. It's a nuclear engineering company. Not only does he lead AMS and doing an incredible job there, he also leads ANS, the American Nuclear Society, which is one of the largest, if not the largest, nuclear professional development organizations, consisting of all walks of life related to nuclear power. Hash is the chairman of that board this year, and just does an incredible job in East Tennessee, the state of Tennessee, but also nationwide advocating for nuclear power. So delighted to have Hash here. And Hash, I guess I'll just get the ball rolling here, my friend. And, you know, there's been a lot of discussion already about where we are today in the state of Tennessee on nuclear power. But it didn't just happen by accident, my friend.
Absolutely.
There was an intentionality here that began several years ago. You were a part of the Nuclear Energy Council, the Economic Development Fund. So talk a little bit, Hash, about how we got to where we are today.
Well, thank you very much. By the way, every time I want to do something with my cell phone, I've got to ask Nikki to do it because with all these PhDs, my kids say, who the hell gave you these doctorate degrees? All right, that's on that. So we are in a great shape. So Tennessee is just labeled, and I got the credit for it, by the American Nuclear Society's national magazine as the state, as the head of the United States on nuclear energy. I didn't write that article, but I'll take credit for it. So, and the reason we are is it goes back to the World War II, goes back to the development of nuclear defense facilities in the United States, and the Oak Ridge National Laboratory, the Y-12 nuclear defense facilities, which are, you know, one of a kind in the United States. So we have a heritage of nuclear in this country. So. The University of Tennessee has the second largest and best nuclear engineering program. So the ingredients for nuclear in this area is amazing. There are other states such as Texas and Virginia that are also doing great, but we are at the head of it. So, and there's a lot of reasons for that. We have an amazing nuclear workforce. We have some of the largest nuclear public utilities of the United States here. So we really are 40% of the Tennessee electricity come from nuclear, 20%. So let me set some stuff straight here. You asked me what kind of questions to ask you. I was going to ask you to ask me to define some nuclear terminologies. Because one of the things that we do that causes problem for us in public is that we do not speak the public language. We have our own jargon. Even us in nuclear industry sometimes do not understand what the other guy says, right? So let me tell you a few things here. So when we say 1,000 megawatt or 1 gigawatt, we are talking about enough power to light up a city of 1 million people. All right, so that's 1,000 megawatt or 1 gigawatt. That's one large nuclear power plant. So when we are talking about an SMR, it could be 1/10 of that, about 100 megawatt. Some of them are smaller, some of them are larger. All right. So when we're talking about an SMR, we're talking about a power plant that can generate enough electricity for 100,000 people. So that's set that straight. The whole of the United States have roughly 100 nuclear power plants, all right, 100 gigawatt, generate 20% of U.S. electricity. All of U.S. electricity today, not the capacity, what we spend today is 500 gigawatt. All right, we are looking to go from 500 gigawatt today in 2026 to 1,500 gigawatt in 2050. In other words, we want to generate 3 times as much electricity between now and 25 years from now. We did the first 500 in the last 250 years of this country. We are trying to triple that in the next 25 years. That's a huge undertaking, and it can only be done by nuclear. I mean, all the other ones are good, but if we want to keep the environment clean, there is no other way. The good thing about nuclear that people don't talk about in these things, it has endless amount of fuel. The nuclear fuel is worth for nothing. You can't do anything else with it, and it's endless, especially if you do what's called recycling. In other words, the good thing about these advanced reactors that you hear about is that when they burn the original fuel, the ashes are better than the original fuel if you can take those ashes and take the stuff out of it. In the United States, recycling of nuclear fuel is illegal. Jimmy Carter, which I have a lot of problem with for other reasons, as you know, made that illegal because of you can get plutonium out of recycling things. So they said, we are not going to do that because the people will steal it and make bombs out of it. Huge mistake. We are going to have to do that. No. Oklo, which is a nuclear company that you all know, just announced they're going to do a $1.7 billion deployment of a plant to do recycling in Oak Ridge. So I just wanted to set some stuff straight. So why do we need 1,500 gigawatt when we only have 500 used for 500 gigawatt? Is a lot of you guys here and ladies who are trying to do this Bitcoin mine. I cannot understand Bitcoin this morning.
He's going to have a better chance of understanding it than me, though.
So, and I'm supposed to know these things, right? So, either you guys do not want us to know what the hell you're doing, or this thing is very hard to explain. Next question.
On that note, yesterday morning, the UT Baker Center, you're probably aware of this, they put out a Powering Tennessee document, which talks about the landscape, the challenges and opportunities for Tennessee's energy future. And they have some 4 energy challenges, electricity load growth, physical shock, so resiliency of the grid through weather events, cybersecurity, things like that, fuel volatility, and then, of course, affordability and competitiveness. And one of the things they mention, Hash, is they suggest future energy strategies. We need to embrace innovation. And they talk about, like infrastructure costs, the costs of successful innovations are ultimately going to be paid by the end users.
Right.
The ability for Tennessee to export energy technology to other parts of the country and other parts of the world increases the customer base that can pay for those successful innovations. I think about advanced nuclear
Right.
from this regard. As you've done a lot of work around the world, is that sort of what the Nuclear Energy Council, did they discuss some of these things?
We did discuss this.
Yeah.
So let me go back to some basics. As you all know, the United States, as wonderful of a country as this is, we do not have a nuclear energy policy in this country. Do you know what that means? Nobody has sat down and said, listen, we need this much power. We're going to try to get this much of it out of renewables, this much of it out of fossil fuel, which is natural gas, because coal is on the way up, and this much of it from nuclear, and this much of it from these other things that are little, like geothermal. Have that. France has that. France has, for example, France says we are going to do this much nuclear, this much other things, and this much. And we are going to take the fuel. And so we have a big problem in this country for that. No, these challenges that you're talking about are all there. But so workforce development, supply chain, these are all true. But my assessment is that if we start building, they're going to come. Look at you guys. You started this whole Bitcoin and stuff industry not too long ago, and it's going gangbuster because there are people like you can make it. So my thing is, these challenges that you think are all very easy to overcome. This country built the atomic bomb in 2.5 years. 70 years ago or 60 years ago, with calculator, with slide rules, right? We cannot do the same thing today in 20 years because of all these things that have changed, the regulations and all. But I really think, and because of the fact that the demand is, when we have the customers, we are going to do it. I mean, if you really, really are good with the power levels that you're talking, the only thing with nuclear is it has two problems. It's very expensive, but it's amortizable. So if you build it, it's going to cost you a lot. Nobody has that kind of money, right? But you can operate it for 100 years. The fuel is almost zero cost. That's why renewables are so popular, because sun and wind is free. Well, so is uranium. Uranium is very cheap. Not today, because we buy it from Russia. We just quit doing those kind of things. But the United States is going to have to get back into it. We can do it. Right, we can do it, but we got to start building. You guys got to. The problem that has not only money is a problem, then the risk. All of this stuff you're hearing about nuclear power today, which makes me so happy, is going to stop or cool down significantly with one accident anywhere in the world. Our record are fantastic. We've been operating 450 nuclear power plants around the world for about 70 years. And we have had 3 accidents, 3 major accidents, 2 of them man-made, 1 of them by nature. So if you look at 3 accidents on 450 nuclear power plants, generating so much electricity, 20% comes in the United States, that's a great record of safety. And that is with the original design, which we didn't know, heat transfer and all that. We didn't have all these computers. Can you imagine going forward, having another 500? The chances of accident in these advanced reactors are almost zero, right? Because the chances of accident in the original old designs, 60, 70 years old design, 3 accidents in 70 years, in 450 nuclear power plants, you cannot beat that. So we are a very safe source of nuclear energy production, and we got to deploy. We just got to get out. China is doing it left and right. China built, listen to this, we built 2 American nuclear power plants in the United States, in Georgia, in 15 years for $15 billion, well, actually $17 billion apiece. China built the same reactors, same ones. And I did the commissioning test of it. Same one in China in 7 years for 3 times less than the United States. Guys, we got to get off and do these things. We can do it. And these are all American technologies. So there is something that has to happen, and it's happening. First, the demand, you guys. Second of all, the financing, which is happening. The government of the United States, Trump, I don't know what you think of Trump, but he's been a great president for nuclear. Really. Some of the things he says I love, some of the things he says I hate.
Energy dominance, Hash, energy dominance.
Oh, we are going to be energy dominant. Nuclear is going to do that.
Yeah, and I saw, Hash, where the Germans are now potentially reversing course on
absolutely
after what they did after Fukushima, and Chancellor Merkel, voted to close down some of their nuclear plants. And, one of the things, Dan, I'll put my old TBA hat on. I mean, one of the things we always talked about was an all of the above energy approach. I mean, we have solar, nuclear, gas, coal, hydro. We don't get a lot of wind in the Southeast.
Right.
That blows and we create electrons. I always said if we could create, electrons from humidity in the Southeast.
That'll work.
That would work. But Hash, what's your view of, you were on the Nuclear Energy Council. I don't know, Braden, I heard Commissioner McWhorter say yesterday that 270 companies have come to Tennessee during this current administration, which is just incredible. What is Tennessee doing differently, and what is what can we do going forward to continue that success? And how do we, I think about nuclear. Maybe it's the most bipartisan energy resource out there. Everybody likes to, maybe on the left, advocate for solar and renewables. On the right, coal, gas, nuclear. But nuclear seems to be the most balanced for bipartisan support.
Exactly. So the reason we are as good in nuclear as anybody else in this country is because, as I said, the fundamentals goes back 70 years ago when we started everything in Oak Ridge to build the atomic bomb and end World War II. So that's the thing. We have politicians that are amazingly pro-nuclear, both in the House. You forgot to mention my great friend Chuck Fleischman. Yeah. He just passed a huge bill that presidents just signed in support of nuclear. The United States, I have been bitching about the fact that if U.S. and if President wants to beat China to this, we are going to have to get the government to put in some money. And when I was saying that 2 years ago, they said, well, we just spent $10 billion supporting some research labs in Oak Ridge and in Pacific Northwest and that kind of stuff, or we spent $20 billion given to this guy or $10 million, that guy. And I told the government, I said, listen, this is not what we're talking about, not $50 billion, we're talking about $1 trillion. At the minimum, $500 billion you're going to have to come up with to get the United States off the ground in nuclear. And they did. So over the last year, we got a lot of money devoted by the United States government in favor of nuclear. $2.7 billion was just allocated 10 days ago to 3 companies. Basically, all 3 have footprint in Tennessee to start the development of what we need for nuclear power. 2 things I want to tell, even though you didn't ask. We call SMR. So remember, this terminology is important. So the small modular reactors are of 2 kinds, SMR and AMR. SMRs are the small ones that are cooled by water, just like the big ones we have. The AMRs are any reactor that's not cooled by water. It's called advanced reactors. So just remember that when we say advanced reactors, we're talking about reactors that the coolant that cools the core is not water. It's either gas or liquid metal or something, right, other than water. There are advantages to AMRs, advanced modular reactors, compared to one of which is that they operate at lower pressure, which is fantastic, because the lower the pressure, the easier to maintain the coolant and everything else. So just remember that AMR are the advanced reactors that don't have water cooling them. SMRs are the one. But people mix them. And sometimes people call SMR both of them, but remember, there is a difference. What did you ask?
Just keep going, my friend.
I learned that from politicians. Ask them any questions, they answer what they want.
We good on time, Ron?
We are, yeah. Give these gentlemen a huge round of applause real quick. We'll open it up to maybe 1 or 2 questions. First of all, Hash, you're born to be a Bitcoiner. With the name Hashimian, you're naturally a Bitcoiner.
Well, I just talked into buying some Bitcoin for my first time. So they want me to put $1 million. I told Jordan, I'll do $100,000 today and see from there.
Can you
I ever
adopt
become-
me? Hold on a second. A 4 kid. Hey, so yeah, we could be sister, brother. It's cool.
It's going to be Nikki's money anyway, so go ahead.
Thank you for the definitions. I think that's really great, and especially at the park, we want to like tell better stories and more stories about the amazing companies here. One thing as well, like Bitcoin is not crypto, and crypto is not Bitcoin. So I like the AMR, SMR differentiation. For these folks, any questions, real quick? One or two before we go to the next panel. Yeah, go ahead.
I guess for both of you, you talk about exporting the energy technology to other states. You know, has there been any inroads to doing it in places like Texas that would be, you know, along the lines?
It's just a question. I don't know how to answer that.
Yes, I think so. I mean, I think there's. I mean, I think about. My old hat on. I mean, TVA. We don't export energy outside the sort of this fence that Congress created back in 1959. But we have seams agreements with other utilities around the TVA fence. Certainly, when we had weather events like the one coming this weekend, make sure that we've got enough electricity in our transmission and system operations team, works with all those surrounding utilities to make sure we've got enough megawatts to keep the lights on. And that's critical. I know they're in the control centers right now. I think as far as advancing and exporting in nuclear technology, I think years away maybe.
If that was you're asking, are we going? Oh, absolutely. We have a lot of technologies here that is unique and is very Tennessee. As they said, we have 356 nuclear companies in Tennessee. We got 160 nuclear companies within 100 miles of Oak Ridge. And so this has been really brewing. The other states are doing just good too. Texas is doing it, even Wyoming, and a lot of other. But we are on top of it in nuclear because of our heritage. Yes, we are the father and mother of nuclear energy in this country. The United States is the father and mother of nuclear energy in the world, but Tennessee is the father and mother of nuclear energy in the United States, and absolutely. Of course, my company works in 26 countries, so we actually are already exporting our technologies, and so are all the other companies that are in Tennessee.
What's been the response there?
Oh, I just came back. Thank God you asked that. I was going to brag about the fact that I was in Paris, France last month, or a month and a half ago, in a conference, nuclear conference. Nikki remembers this. 27,000 people were in Paris. 27 in a conference called World Nuclear Exposition, right?
Paris, France, not Paris, Tennessee.
Paris. If that conference was in Paris, Tennessee, I probably wouldn't go. So anyway, what I want to tell you is that, so I'm walking around, I'm president of the American Nuclear Society, so I get a little bit of things. Everybody in the world that can do business with the U.S. love to do business with the U.S. Some people don't like Trump as much, but even with that, they all like to. So everybody wants our technology because they think U.S. knows how to do it. So we're going to have a very easy time exporting. The other thing I want to tell you, Nikki and I were in this same conference, I would think about 10 years ago, and same conference didn't even have 10,000 people. 27,000. And this is only France. And France is not as nuclear. Well, France is 70% nuclear, but we have 3 times as much nuclear power here as France. So you can see that nuclear is really going gangbuster all around the world. Even Germany, as somebody says, they shut all the plants, now it's coming back.
Rod, one more question, Hash. Just I thought of skilled workforce, future workforce. University partnerships across the state of Tennessee, across the Southeast. It's important, I think, for the
absolutely. I think we are doing a lot. I think we probably are overreacting to the workforce problem and the supply chain problem. I think we have what it takes. We don't have it today, but remember. Everybody is talking about workforce, but nobody's building a nuclear power plant. Now, what happens if you guys all of a sudden go away, or we have a nuclear accident and all? So we cannot put out 100,000 people pronto when We don't know whether or not they're going to have jobs. So there has to be a balance between this amazing push toward workforce development. We need it, and it has to be done. And we need it at the lower level. We don't need much PhDs. We know how to do. Remember, nuclear power plants don't do a big thing. They just boil water. Seriously. Seriously, you just boil water. You can put some charcoal under a tank and boil water. So it's not a big deal. So we don't need that. In a nuclear power plant, that there's 1,000 people there, there's only 10 nuclear engineers, and they barely got the job because we don't need nuclear. We need welders, we need plumbers, we need electricians and all that, and that's a huge shortage. Yeah, so Tennessee is doing a great job responding to that. Thank you so much.